The broadcast is now starting. All attendees are in listen-only mode.
Hello.
Hello, Tom. We can hear you.
Hi and welcome. I'm Tom Harris, and you've joined us for the Solid Edge 2020 Model-Based Definition webinar today. We'll just hold on for a couple more minutes while other people arrive. All right, we'll kick off now, and other people can join us if they wish. Today we'll be looking at model-based definition, and you've probably seen slides like this one here. Digitalize your product development process and transform your business. But the reality is, how do you do that? Okay, a lot of people don't know how to digitalize your product development process or transform their business. And so typically what's been happening is people have continued using CAD in much the same way as they used a drawing board. They develop models and they do interference checking, but it hasn't transformed their CAD or documentation process. So Today we'll be having a quick look at model-based definition, what it is and why we would use it. So to get your head around model-based definition, what it is it's an electronic model definition and distribution system. It's all very well and good to have an electronic model that's perfectly defined on your computer, but if you cannot give that model and the complete definition to your suppliers, then realistically it's useless. So what model-based definition is everything needed to make your product, all of the information needed to make your products. This includes machine readable product manufacturing information in the form of STEP AP242, which is an industry recognized format there. So this is what model-based definition is. Why would we want to use it? Well, I'm sure if you're in manufacturing, you have probably come across the scenario where someone created your parts based on an old drawing, or someone checked the parts coming in based on an old drawing. Now, this is a problem that's always been around since basically paper drawings. And what model-based definition can do for your company is it allows you to use what's called single source definition. You have a model, and that model doesn't even get copied. It gets distributed electronically, so everyone is looking at the same source file. This completely removes the old version errors that paper-based model definition was very prone to. Model-based definition is also used for compliance, particularly with mil specs or mil standards and ASME manufacturing standards. So how does Solid Edge help you with this model-based definition? Well, product manufacturing information, or PMI, has been a part of Solid Edge for quite a few years. Solid Edge gives you tools to dimension your models, and I don't just mean basic dimensions, all tolerances. It allows you to do annotations like datum frames, datum targets, all sorts of different manufacturing information. Basically, what you need on a drawing has now been made available in the 3D environment through various annotations. Next, you've got to have collaboration or consumption of the model. And Solid Edge has had quite a few tools to do this. Solid Edge Portal has been a quite recent tool. This is a cloud-based collaboration tool. Also coupling with that is the Solid Edge Viewer. Now, the Solid Edge Viewer is a copy of the file, and it's not a single source definition, but it was an earlier step towards that. You can still use these tools as well. The JT format is another form of consumption or collaboration for model-based definition. JT format has all sorts of nice things in it, and it's a Siemens product or Siemens specification, and it's used very, very widely. It's an ISO certified specification. Next, your CAM product can consume the model directly. This is particularly the case with either Solid Edge native files, which contain all the product manufacturing information. It can be with the STEP files, the AP242, as mentioned just before. And all of the tolerancing and things like that can be consumed by CAM to give you a much easier or quicker programming process. Next, however, we've got 3D PDF. Now, this is a very, very powerful collaboration tool. I'm not just talking about the ability to write out a 3D PDF from your 3D model. Okay, that has been around for a while and it is good, but it does not include all of the model information. It's basically a 3D view with some PMI. What we're talking about here with the 3D PDF is the model-based definition tools. It should actually say MBD, not MDB. Model-based definition tools in Solid Edge. This allows you to transmit or communicate all model information. That is the actual model itself, as well as additional specifications. They might be included in the PDF template, or it might be included as separate attachable files. And it is template based. That is a key to this because that speeds this process quite dramatically. So what do we want to, or what is the cloud collaboration? Now, you've seen the Solid Edge portal, stores and shares all sorts of file types, all sorts of common CAD formats. It allows for viewing and marking up, as you can see on the slide here. It also allows augmented reality using some various different devices, and you get free storage with it. This is included in Solid Edge. Just have a quick look at, this is a pre-recording of some things you can do in the Solid Edge portal. You can view your models, explode them, section them, all of these typical model-based definition tools to allow you visibility inside your model. You can also do your markups inside the Solid Edge portal. So that's just a very, very quick look at model-based definition using the Solid Edge portal, and includes measuring as well. Some of the other tools for consumption of model-based definition information, the Solid Edge mobile viewer and JT2Go are earlier versions. Solid Edge mobile viewer allows you to take, for example, an iPad and basically view either your 3D models with all PMI on it or your 2D models wherever you might want in the workshop. Quite a useful tool. Then you've got JT2Go. JT2Go works on iOS devices, Windows-based devices, including normal PCs. You can get Windows apps you can get JT2Go apps, I should say, from the Windows Store, Google Play, and there are also downloadable and installable desktop apps. This allows for interactive viewing of 3D models and 2D drawings, as well as markup and measurement on some devices. So there's quite a few tools already out there for consumption of model-based definition. So how do we actually generate the model-based definition information in Solid Edge? Well, you can see on the screen here, we have in Solid Edge 2020, and it's in 21 as well, we have enhanced PMI. This is basically bringing model-based product manufacturing information up to the level of the manufacturing information that is transmitted or put on normal 2D drawings. It's to allow full communication in the 3D environment. You can do enhanced section cuts. We'll have a look at some of this in a little bit. We can use PDF template creation. We can actually create templates for our 3D PDFs, and then basically you have an ability to automate your PDF output. So let's take a look at this. I'll just switch over to Solid Edge now. Oops, where am I? There I am. And we've got a model that is part of the WashTec data set from the Solid Edge launch. Now, it looks like a fairly basic system. You know, there's a tap here, there's a couple of inlets, outlets. It's a fairly basic system that we're having a look at. and it's got a couple of section views already stored in the model. And if I turn these on, you can see that it's a form of filtering system. Okay, there's one of the views, and we'll switch over to the next section view. And oops, turn off the first one. You can see the kind of advanced section views you can create here. Now, with sectioning, you have the ability to section by plane. Simply select a plane, drag it up and down. You can just tap X, Y, or Z to change the plane that you're cutting this on. You can then move it in or out as needed, and or rotate about any of the axes. You can also, I'll just go back to the Y, accept that. Oops, sorry, didn't mean to accept that. You can also add additional cutting planes. Okay, I'll flip this one, rotate it a little bit, and I'll drag it up to give me a look through or into the top of that filter box area as well. And so you see you've got various tools, and these section by plane tools are very, very useful for creating quick, detailed section views for communicating your information. Now, what else do we typically have in model-based definition? Well, we normally have product manufacturing information. Now, you can see here I've got various product manufacturing dimensions, clearances, annotations, including, torque settings, things like that. But how do we actually utilize all of these? Well, in the product manufacturing information, you can see I've got dimensions, annotations, but I've also got model views. If I apply one of these views, you can see it controls what dimensions, annotations are displayed, and it also controls what parts are shown and hidden. So you can generate numerous different views to express how your product is to be manufactured. Now, one of the nice things about this is if I click on my annotations, you can see that it highlights the areas that are to do with that particular annotation. And I can add additional geometry in there if I want. I don't in this case. So I've got quite a bit of ability to show what I'm talking about with these annotations. So that's all good. We can create model views. That's using the view command. Basically, you set up with the PMI annotations and parts shown or hidden that you want, and then you simply create a view and give it the appropriate name. So what do we do with all of this information? How do we get it to the customer? Well, we have a published 3D PDF. Now, you might think, well, yeah, that's all good, but I could have saved as translated a long time ago. And you'll notice that I have 3D PDF documents there. That is true. However, this takes it to the next level. And the way it does that is it has the ability to generate these PDFs according to a template. I'll just click on the template editor, and you'll notice basically starts with a blank page, but it has all of these options. What are these options? Well, I might place a 3D view of my part. Now, this is a 3D view of the model itself. I might want to add a view carousel to the bottom of that. Now, what this view carousel is, you saw all of those model views I created. Well, the view carousel is a way to basically navigate between all of the different views that you have created. So we can set these up, we can size them as desired. I might bring that over that size. I'll add a bill of materials table as well. Now, that might be a little bit too big now. And you can set up the bill of materials and how you want it to be laid out and all of that kind of stuff. I can also add document specifications or whatever I choose to. Now, with these PDF texts, I can actually add information as desired into this PDF text. And then I've got all of my other normal tools. So once I've done all of that, I save that, and typically I would save that in my Siemens folder, Solid Edge, Templates, 3D PDF Publish. Okay, that's my folder. And I want this to be Tom's assembly template. Okay, I'll just call it Tom's assembly. Okay, validate. No, there's no other documents by that name. Save that as my template. All right, so now I've got a 3D PDF template. What do I do with that? Well, when I choose to publish this document as 3D PDF for model-based definition, the first thing it says is, what template are you going to use? You'll notice that Tom's assembly is there. Now, some of these other templates are set up a little bit nicer, so I won't use that one in particular. But for example, I'll use an assembly landscape template at this point. I'll publish it to a model-based definition published folder, and I'll give it that name. Notice all of the PMI model views. Okay, I can choose to select all of them or just some of those views to be put into this 3D PDF. I can open up the document in the PDF viewer after I've created it. I can add the custom file properties to the PDF document. This is a nice one here. I can publish HTML version of this 3D PDF, particularly useful if you're not intending to distribute this data by PDF, by PDF files, but if you want to add it to a website or something like that. And I'll add the next and previous action buttons in the PDF as well. Now I can also add different attachments. You saw the JT file there, and you can see the step file there. I'll get a machine readable step file in here. Additionally, if I have, for example, a PDF specification, I can go and add and browse my various specifications and add them into my 3D PDF. So all of the information I need to manufacture these components are all stored in the one 3D PDF. So as you can see, when I said single source, I mean single source. This is a place where you can come to get all of your manufacturing information. It goes away and grabs all of the 3D model data of the whole model, and it puts it all together, adds the attachments, and then in this case it's generating the step file attachment, and then it will add the attachments, collate it all into a single PDF document, and then it will open that PDF document right here on the screen so we can see what we've got. So it takes a couple of minutes, yes, but, well, normally not a couple of minutes, normally about a minute all up, and then it finishes and you've got a single source definition. At the moment, it's publishing the 3D PDF. It is a lot quicker if you don't publish to HTML, which I have done, but I wanted to also show you the the HTML definition that you end up with. I'm just going to bring my my model down here. You can see that it's actually just finished creating the PDF and the HTML file. Let's have a look at that. As you can see, this is already quite different to your typical 3D PDF. Number one, it's all laid out with headings and tables. I'm not sure if you can see that. Let me zoom in a little bit more. I just want to show you the specification table. I should have made that a little bit larger. All of your manufacturing information there. You can add disclaimers, company logos. Let me go back to full page. All of the information. You can have manufacturing notes, dimensions, tolerances. But I'll come back up to the main page, and you can see that my model is all quite easily rotatable, spinnable. If I click on a part, it highlights the part in the tree as well, in the BOM. I can click through the BOM and it's all completely interactive, two-way interactive. So it's highlighted that part there. Now here is my view carousel. Let me just zoom out a little bit more so you can see it all. Here's my view carousel. The base view is what we started with. Remember how I'd set up all of these views. I've got the internal view. I've got the lid fixings. And there has, the bolt and the washer and all of the torque in this case. I have my filter fitment information. All of the particular manufacturing information, and then I have my typical views. So we've got a lot of information here for how to manufacture this particular assembly. Okay, close that. Let's have a look at the actual HTML. Now I'll just drag this window down. Notice HTML, pretty much all the same functionality. Zoom in, zoom out, select, it highlights, select there, it highlights. So it's two-way highlighting. All of my basically carousel information is there. If I want to go into the tree, I should have shown you this on the PDF as well. You can do this in the PDF. All the information, properties, so on and so forth, for each of the parts in the assembly. So it's quite a comprehensive document that you can create using this. However, at the moment, you've seen only a 3D assembly. So what about grabbing other types of data? Well, I'll just quickly open up a part so you can see that kind of manufacturing information. This is where you start having to need, datum targets, all this kind of stuff, and specific feature information in order to enable proper manufacturing. You can see that I've got a few different views here and quite a lot of product manufacturing information for this particular part. This is where your views are particularly useful because you set up views depending on the information that you need to show in that view. Okay, so all of this is set up, ready to go. How do I again get the model information out? Well, I go to my PMI tab again. I could use the template editor if I didn't have one already, or in this case, I'll use the 3D Publish. Again, I don't want an assembly landscape. I want a part landscape this time. Slightly different template. Give it that name. I won't publish the HTML this time, make it a little bit quicker. And I will publish that. Grabs the model data, generates the attachments, and quickly drops out the step file. There it is. You can see I've got my views showing the manufacturing information in the particular orientations that make sense for the view. Now, I'll just move that over. I can come over here to the model tree. Notice I've got all my PMI information, all of that kind of stuff. I can turn on or off any of that at will. I've also got the attachments file. Now here we have a step file. Okay, I'm going to open that step file. I will open it here. Fires up Solid Edge, opens the step file, but what you'll notice here, I want to bring it into the part environment. What you'll notice here is that it should have all of the 3D PMI right there, and you can see all of that. Now, how do we make sure it's got the 3D PMI? Well, when I first, I'll just close down this instance of Solid Edge because it opened up a new one. When it saved out the step file during this operation, what it actually uses is it uses the options from the last time you saved out a step file. So if I have a look at the options here, notice Export PMI is turned on. Whatever options you use here is what it will use while it is generating the step file in this case. When you, in order to make sure you import it all correctly, it will use the options that were last used. If I can get a step file somewhere. Step, here we go. So if I grab a step file and select options, notice I've selected to import PMI. Now, if you don't have both of them set, then the step file in the 3D PDF may have the PMI, but if you don't import it, you won't see it. If you don't export it, then the step file in the 3D PDF will not have the PMI attached, which means your machines that can read 3D PMI will not have it attached either. So that's a really quick preview of the types of information that you can transmit in the 3D PDF environment. Now, I just want to quickly open up one of the previous model that we looked at before, and the assembly. There we go. I want to show you another function. At the moment, the section views in Solid Edge don't come across as section views in 3D PDF. However, that's not so much of a problem because the 3D PDF has the ability to do section views as well. And I'm going to flip that. You can see how you can very, very easily generate your 3D or see your 3D PDF section views, and it's got all sorts of options in, adding section caps, for example. At the moment, it just cuts. If I add my section cap, it makes it look a little bit more like your typical solid edge section view. So just because the specific section PMI section views don't come across doesn't mean you can't do that functionality in the 3D PDF environment. All of the functionality is still there. There is a little bit more, however, that we still haven't quite looked at. And this is if I need to create, nice animations and things like that, I might want to create, a really, really fancy animation of this component. Now, we all know that Solid Edge is linked heavily with KeyShot, and I'm just going to view my base again. You'll notice there's a part here, and you might have seen it in some of the 3D PDFs. What this part is for is this is actually what we would refer to as a sectioning part. KeyShot has the ability to section views with a part. Now, how do we actually set that up in Solid Edge so that we can display those movies to carry the information through? Well, what we want to do is we want to create a linear motor on this part. I'll say 10 centimeters per second. Hopefully that'll be right. We'll see how we go. Now I want to simulate that motor. I'll do 10 seconds, yes. You can see how the part is basically going all the way through as we get there. So what we now want to do is we want to animate this particular model in KeyShot. So I click KeyShot Animate. I can select whatever quality I want. I'll accept that at the moment. Say OK. It then generates the KeyShot BIP file, opens KeyShot, and brings us into the file. Now, at the moment, you can see this part, which is not really what we want. However, you'll notice in the KeyShot materials, there's a material type called a cutaway. And you can have various different types of cutaways. You can have red capped cutaways, which would be very similar to what we just saw in 3D PDF. You can have cross hatches, double lines, all these different types. I'm just going to go a red cap section cutaway. I apply that cutaway to the part and it disappears. Okay, why does it disappear? Well, all it is a cutaway. Now I want to change my view. That pretty much concludes our presentation. If anyone, there we go, paused finally. Or you can give us a call on our support hotline, 1300 883 653. So we've got a few questions here. Let me just have a look. Oh, just regarding the streaming stopped. Unfortunately, that was my computer freezing for a couple of seconds. That's all that was. So, are there any other questions? No, doesn't appear that there's any other questions in the questions pane or the chat panel. If you do come up with any questions, please send them through and we will come back to you either by email or Solid Edge. By email or phone. Oh, hang on. Yes, I've got a question. The 3D PDF is great, but are the file sizes larger? Yes, of course they are. They are. It does utilize the JT format. So as you can see here, the 3D PDF, which included the step file and the 3D PDF, was 5 meg. So it's not a particularly large file, but it was 5 meg. Notice the HTML was a lot larger than that. If you don't include the step file, then the file size is, of course, much smaller. JT is by default, JT or 3D PDF, it uses the same thing, is by default a much lighter format than step. All right, any other questions? I can't see. Thank you, Maran. Excellent. All right, well, any questions, like I said, come back to us and we'll hear from you then. Thank you very much for attending.